Welcome and thank you for joining. In this lesson, we'll discuss various strategies to solving trigonometric equations, which are equations that involve one or more trig ratios of unknown angles. So let's start off with one of the simplest examples of a trig equation, sine of x equals 1. In this case, we're trying to solve for the unknown angle x when we know that the sine ratio of x equals 1. Step number 1 to solving this equation would be to use the calculator to determine the angle. So we have x equals inverse sine, and by now we should know how to use the calculator to access the inverse of sine or the arc sine option or function. So for this we use either the second function or shift first, depending on how your calculator displays it. And then we have to press the sine function. And once you've done that, you type up the value of the sine ratio, which in our case is 1. If your calculator is set to degree mode, then it will give you the angle of 90, which we must convert to radians, and that is because the domain in our equation is in radians. So 90 degrees to radians would be pi over 2. Next, we have to search for other potential angles that may share the same sine ratio within the domain 0 and 2 pi. Recall that there is more than one angle that shares the same domain within 0 and 2 pi, and that's something we've discussed in the prior lessons. So to find two angles that share the same sine ratio, we reflect the terminal arm about the y-axis, and that is because the sine ratio depends on y. To find two angles that share the same cosine ratio, we reflect the terminal arm about the x-axis, and that is because the cosine ratio depends on x. And to find two angles that share the same tan ratio, we reflect the terminal arm about both x and y-axis, and that is because the tan ratio depends on both x and y. So step number 2 would be to draw the angle on the Cartesian plane. So the angle that the calculator gave you. And once we draw the angle on Cartesian plane, we are going to try to determine if there is any other angle that would have the same sine ratio. So the angle pi over 2 always start from positive x-axis, go up or counterclockwise, and as you can see in here, the terminal arm has landed on the y-axis. So if you want to reflect the terminal arm about the y-axis, then that will result on the same terminal arm, which means that this would be the only angle that will have a ratio of sine equal to 1. So let's take a look at a graphical explanation of our answer. So what you see in here is the graph of sine function or sine of x. And as you know, sine of x equals 1 is what we are trying to solve. So this would be the function y equals sine of x. And in the domain of 0 to 2 pi, the sine of x will be this one. So this is a portion of the graph we are looking at because that's from 0 to 2 pi. So sine of x will have a value of 1. This is the line y equals 1. As you can see, it intersects the sine of x only at this point where x equals pi over 2. And we are talking again about this specific domain, which tells us that this would be the only solution that we get for this equation. And this kind of explanations, I hope, can help you understand how to check your answers by using graphs. So you can easily graph the equations on Desmos, and then you can find or determine whether the solution you found by using the algebraic method is correct or not. So step number 3 would be determine the angles with the same ratios in the specified domain. So let's write that down. With same ratio within the specified domain, which in our case was from 0 to 2 pi. Beautiful writing too, huh? Domain. Oops. Okay, now let's take a look at another example very similar to the previous one, but this time we will expand the domain between negative 2 pi and positive 2 pi. So step number 1 again would be to use the calculator to find the angle. So inverse sine negative 1. Set the calculator to degree mode for an exact answer. In our case, we'll get the angle 270 degrees, which we must convert to radians. And that's because our domain is given in radians. So that would be the angle 3 pi over 2. Step number 2 would be to draw the angle. So we drew the angle on the Cartesian plane. That would be the angle 3 pi over 2. We'll start from positive x-axis, go pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2. So we have landed again on the y-axis here, which means that if we try to find the second angles by reflecting the terminal arm about the y-axis, we will land on the same spot, all right? So the terminal arm, this terminal arm will be the only one that can give us a solution for this equation. So step number 3 in this case would be to determine the angles within the specified domain. Remember that the domain given is between negative 2 pi and 2 pi. So the positive domain is read this way, so counterclockwise. So the only angle that we can read in the positive domain would be 3 pi over 2. Now we're going to read the domain in the negative direction. So starting from the positive x-axis always, this time we're going down or we're going clockwise. And we stop where we hit the terminal arm and we see that we have landed at negative pi over 2. So x equals negative pi over 2 would be our second solution. So let's take a look at a graphical representation of this equation. So we have sine of x equals negative 1. Here is the curve of sine of x. And I will highlight only the domain between negative 2 pi and positive 2 pi. As you can see that the value of sine of x will be negative 1. That's what the equation is giving us. So we want sine of x to equal negative 1. That would happen at these two particular points. So as you can see, the only points where the graph will have a value of negative 1 are at x equals 3 pi over 2 and x equals negative pi over 2.